Welcome to our demo on the MAU Orchestrator, a system to detect quality issues, bugs in software artifacts. Nowadays, we engineer a lot of software based on artifacts that we find in online repositories, sometimes also called hubs or marketplaces. In these repositories, we find artifacts which are programming language specific, as we can see here, along with a lot of metadata that describe the software packages, as well as the implementation. And we are especially interested in the behavior of the software at runtime. So everything we do not necessarily see advertised on the marketplaces, repositories, or hubs. We have a number of language-specific artifacts. We also have operating-specific software packages, as we see here, libraries or applications. We have commercial ecosystems by large players. And again, we see mostly functional descriptions as well as metadata, but we do not really see the behavior. We do not really see security properties, as well as consistency information. The same is true for generic code hosting, like we have here the case of GitHub, because we do not have dedicated artifacts for Docker files or Docker Compose files. We do have a dedicated Docker Hub, which, however, also does not carry that information. And as engineer, we are, of course, interested to find out what happens to our application in case we integrate those artifacts. There are specialized registries which have a few of those characteristics because they run scans in the background. However, again, we would like to have a systematic way to find out about the quality characteristics, bugs, security issues, consistency issues in artifacts across all technologies, across all of the repositories and marketplaces. That is why we propose a federated system called the MAU Orchestrator, MAU standing for Microservice Artifact Observatory, so that we can analyze all of the software artifacts which are offered and which make up a large share of our online applications as dependencies or as derived software which we derive from those artifacts. So that extends into the architecture. Here you see the architecture consisting of a number of federated nodes running the MAU orchestrator by operators achieving consensus about the observations they perform by assessing the software, acquiring metadata from the software, acquiring test information, runtime information, building up data sets, and by achieving consensus, a ground truth is produced, which is then the basis for automated informed decisions by, for example, software engineers. But the data can also be assessed by data scientists or researchers to find out evolution, trends, as well as general characteristics of software artifacts that are used in cloud environments and in other environments where microservice-based artifacts play a role. The concrete demo will start with showing how a node is bootstrapped if you want to join the federation. Of course, you can run all of the artifact checks standalone. Here we show how a Docker Compose file is used to launch the node and connect it to the federation. The connection is performed by changing the appropriate environment variables in the Docker Compose file. That allows you to connect to other instances which also perform the checks and which may have diverging results. We start from scratch cloning the MAU orchestrator Git repository, entering the directory and running the Docker Compose file, launching all the Docker containers that are needed to operate MAO orchestrator, including a relational database and a decentralized key value store. Afterwards, we launch the orchestrator itself, which is starting up. So once we have an orchestrator running, it is empty. We need to register a number of tools which perform the actual assessment, and we may also register certain data sets which are, however, populated in any case by the assessment tools. There are a number of tools already available and registered which produce those data sets. Data is structured in a way that each data set at each node are stored by different versions so that we can perform consensus voting across all of the microservice artifact technologies and across all of the nodes. So we are launching the framework and we are launching the registration of a tool, which is the assessment of all the artifacts in the Artefact hub that we have seen before. We see that it is properly registered, and from that point on, we get the health monitoring with regular notifications. Now we have added a first data set. We can start with an empty data set or one which already exists. And we can also verify that the data set has been registered successfully. Now we would like to run the tool in ad hoc mode or in scheduled mode. For example, we may want to assess the quality of a certain artifact technology each night, or we want to integrate the assessment of a certain technology into a CI/CD pipeline where we need ad hoc execution. So on that slide, you can see the syntax for setting up a schedule where the tool would run according to the defined times. And furthermore, the dataset would be produced locally or would be placed into a reproducibility system such as Renku so that other researchers can easily verify how you achieved those results. Certain metrics describing the artifacts which are part of the analyzed repository. Now we see how we are actually running the tool, how we are assessing certain characteristics of artifacts stored in the Artefact hub. This takes some time as all metadata is downloaded, and depending on the software technology, the implementations are also downloaded for further inspection, for dynamic assessment, for trace collection, and so forth. This takes a couple of seconds for the Artefact hub, which already carries a certain number of Helm charts and related artifacts that are used to build cloud-native applications on top of Kubernetes. Now the check has returned. We find that we have a lot of data collected, which we can then compare with other nodes in the same federation to achieve a ground truth which can be trusted because we assume the operators are independent entities. Now, in case there are diverging observations, we would like to achieve consensus. So what you see in the following is that we have 3 nodes participating in a federation. One of them has maliciously altered values. We would like to figure that out. So these are the characteristics we have recorded. Those are the ones you just saw in one particular snapshot. This is a time series where we have collected this data over several days, now using Docker Hub, or alternatively the serverless application repository with the 2 malicious values in the stars column and in the language column. We would like the consensus mechanism to find those discrepancies automatically. And this is the raw syntax format of the observations which are fed as input into the consensus algorithm. Now we have the algorithm running. So on the left side, we see that all of the remote data sets from all the peers registered as nodes in the federation are cloned and prepared for comparison, and all differences are either resolved automatically or, in case they cannot be resolved automatically, are recorded as permanent discrepancies, so no consensus can be achieved. Here we verify that we have the right information available. We see again the malicious modifications of the stars and language columns in the datasets. And now we run the consensus algorithm in the background. We confirm that this malicious modification would, of course, lead to certain modifications in the mean average values as well, which is why it is important to eliminate it. And here we see the cleans dataset where the malicious modifications have already been removed. And here they have been isolated. Those are then either resolved or permanently recorded as disagreements between the nodes which perform the observation of the artifacts. So that in the end we have one ground truth dataset that tell us about the characteristics of each cloud software artifact, each microservice artifact, which may be part of a composition and therefore determines whether or not our applications that depend on those artifacts have certain characteristics which we can guarantee, or about which we have at least the knowledge that at a certain point in time they used to have a certain set of characteristics which may be very useful for regulated environments such as banking and insurance applications running in the cloud, where we need to verify that only whitelisted software artifacts are being used for security reasons, for example. So we want to make sure that none of the entities making up the application is affected by a CVE in any case. If you're interested in scanning microservice artifacts, please visit our website. Thank you for watching, and we hope you enjoy the rest of the Middleware conference.